Hello there, Mr. Sutton here, bringing you the Algebra 2 2.2.3 homework solutions or the Algebra 2 Honors 2.2 Part 2 homework solutions. Either way, this is going to be characteristics of quadratic functions in standard form. For Algebra 2, there's 6 problems we'll be going through. If you've the honors, then there's one extra problem at the end. So let's take a look. For this problem, we're trying to graph this y function. Since this is in standard form, ax squared plus bx plus c, I'm going to find the vertex first by using the vertex formula, negative b over 2a. So that's going to be negative 2 over 2 times the invisible 1 here. Negative 2 over 2 gives us negative 1. And then I'm just going to plug that back into the function to get the y value of the vertex. So that's going to be, let's see here, negative 1 squared is 1, 2 times negative 1 is negative 2. So 1 minus 2 is negative 1, plus a 1 gives us 0. All right, so we have a vertex at negative 1 comma 0. Let me graph that out while I'm doing stuff here. So we have negative 1, 0 right there. Now we also can very easily pick out the y-intercept. That's this constant here, the c value. So that's a y-intercept at 0 comma 1. So that's up here. And since I've got this, I can just use symmetry now to reflect that y-intercept over this axis of symmetry that goes through the vertex. So that reflects over to negative 2 comma 1, and that gives us our third point with which we can now graph the parabola. For this problem, since we're in standard form, let's go ahead and find the vertex with that vertex formula. X of the vertex equals negative b over 2a. So in this case, that's going to be a negative invisible 1 right here over 2 times 0.5. Now this looks kind of gnarly, but 2 times 0.5 is just 1. So this is just negative 1 over 1, or just negative 1. All right, let's plug that back into the f function to get the y value of the vertex. So we have negative 1 squared, which is just 1. So this really is just 0.5 here. 0.5 minus basically minus 4. So that's going to come out to negative 3.5. And let me just, so that's a vertex at negative 1, negative 3.5. Let me graph that now. So negative 1, negative 3.5 is down here. And this negative 3, the c value, gives us our y-intercept of 0 comma negative 3. So that's going to be right here, so pretty close. There it is, over there, 0, negative 3. But now we do have a reflected point over here, over the axis of symmetry, so I was going to put this point on there anyway, just put it on a little early. Now we've got our 3 points that we can graph our parabola through. And there it is. For this problem, we're trying to graph the g function. This is in standard form, so we're going to use negative b over 2a to get the x value of the vertex first. So let's write that out. Negative b over 2a, that's negative 3 over 2 times negative 1.5. So basically negative 3 over negative 3, which is conveniently just 1. It doesn't always come out to 1, but hey, we'll take it when it comes here. So we've got now 1 getting plugged back into the g function to give us the y value of the vertex, because that was just the x value. So we have basically negative 1.5 plus 3, which is 1.5, plus another 2 is 3.5. So 1 comma 3.5 is our vertex. All right, let's put that on the graph. 1 comma 3.5 right there. And now for the other value here, we have a 2 for the c value. That's going to be our y-intercept of 0 comma 2. So that's right there. And we can reflect that over the vertex to get a third point. With 3 points, we can now graph the parabola through those and call it a day on this one. On this problem, we're trying to find the min or max value of the function along with the domain and the range and when it's increasing, decreasing, all the things. So it would be most useful to get the vertex. That would give us a lot of good information. The vertex, this is actually, I mean, it's in standard form, but it's also kind of in vertex form. You could think of this as being like x minus 0 quantity squared, in which case the x value of your vertex would be just 0, and 7 would be the y value. So 0 comma 7. It would also be nice to know which way this parabola is opening so we could get a quick sketch of it. Since this a value out in front, this 9, is positive, that means we're opening up. So this looks like an upward opening parabola with a vertex of 0 comma 7. So that's just a quick sketch, no x or y axis, but it'll help us answer these questions now. So for finding the min or the max, we know that since we're at the bottom of the parabola, 7, the y value 7, is going to be the minimum value there. Now for the domain, that's always going to be all real numbers for these quadratic functions. They can take either negative or positive values or 0, it doesn't matter. Goes forever left and right. For the range, this one is only going to hit values that are above the y value 7. So we need y greater than or equal to 7. And then for the increasing versus decreasing, well, we're increasing from 0 onwards, from the x value 0 to infinity. So increasing for x greater than 0. And then we're decreasing for all values that are less than 0. We're going down as we move to the right. So that's everything. To analyze the g function here, figuring out min, max, domain, and all that other stuff, we're going to start by getting the vertex. This is in standard form, and we're going to need that vertex formula, negative b over 2a, to get the x value of the vertex. So that's going to be negative 18 over 2 times 3. Negative 18 over 6 is going to give us negative 3. And if I want the y value of the vertex, which I do, I'm going to plug that back in. So let's see here. I got a little bit of mental or maybe not so mental math to do here. We've got 3 times 9, which is 27. And then we're subtracting 54, so that brings us to negative 27. Subtract another 5 from negative 27, we have negative 32. I think I did that right. All right, so we have a vertex at negative 3 comma negative 32. Now, which way is this thing opening? Because that would be good to know as well. Since this 3, this a value, is positive, that means our parabola is opening up. So that means we have an upward opening parabola, a smiley face, with a vertex of negative 3, negative 32. With that visual in mind, let me see if I can now answer all these questions they're asking. For max versus min, well, we're at the bottom of the parabola, so we definitely have a min, and the y value down there is negative 32. So we have a min of negative 32. For domain, that's always going to be all real numbers for quadratic functions. For the range, we hit all the y values that are above negative 32 or negative 32 itself. So y greater than or equal to negative 32. For increasing, our function is moving up as we go to the right after we get to the x value negative 3. So x greater than negative 3 is our increasing interval. For decreasing, we are decreasing until we get to negative 3. So x less than negative 3 for that piece. For this problem, I want to find the min or max of this function along with domain, range, and increasing, decreasing. To get all that information, it would be helpful to know the vertex and which direction this thing is opening. So since we're in standard form for the vertex, I'm going to go with negative b over 2a to get the x value of my vertex. That's going to be negative 4 over 2 times negative 1. So that's 4 over negative 2, which is negative 2. To get the y value of the vertex, I need to plug that back in for x. So we've got negative 4 plus 8, so that's going to be positive 4, minus 2 gives us 2. So negative 2 comma 2 is our vertex. Since the a value here, this invisible negative 1, is, well, negative, that means that we're opening down. So my parabola looks something like this. We have a frowny face with a negative 2 comma 2 at the top for the vertex. Now, since that is at the top of the parabola, that makes 2, the y value 2, the max value. We can see that on our little sketch here. And for the domain, that's always all real numbers for quadratic functions. For the range, we're hitting all the y values that are less than or equal to this 2 right here. And then for increasing, we're increasing until we get to x equals negative 2. So we'll say x less than negative 2 for increasing, and then x greater than negative 2 for all the decreasing. And that's it. For this problem, on the honors problem set here, they're telling us that the height in feet of a basketball thrown at 45 degrees can be modeled by this equation right here. Y equals negative 0.02x squared plus x plus 6. X is the horizontal distance in feet, and again, y is the height. in feet. So we want to find and interpret the coordinates of the vertex of this thing. Since we're in standard form, we'll use negative b over 2a to get the x value of the vertex. So that's going to be a negative invisible 1 here over 2 times negative 0.02. And I'm just going to go to Desmos to run those numbers. So here I am in Desmos. Let me do negative 1 divided by 2 times negative 0.02, and that all comes out to 25. Cool. And now let me get the y value of the vertex by plugging 25 back into the original function up there. So to Desmos again, I'm going to go to deal with this. We have negative 0.02 times 25 squared plus 25 plus 6, and that comes out to 18.5. All right, so we have a vertex of 25 comma 18.5. Groovy. So what does that actually mean? Well, what this means is that the basketball is achieving a maximum height of 18.5 feet, and that happens when it has gone a distance of 25 feet. So maximum height 18.5 occurs when the ball has traveled 25 feet horizontally. Boom.